Awesome. Oh. Hi, everyone. Thank you for that great introduction. WebVR is a very exciting world. I really do believe in. And how many people just dabble with it? Anybody? Oh, few. Great. So this talk is for you. I'm so glad you're interested. A little bit about myself. So I work at Narwhal. I don't know if you heard of it today, but there's a bunch of us here. Justin is right here, Victor and Jeff and me. So what we do, and also I'm a Google developer expert for Angular team. And you can follow me at iSomething on Twitter. And what we do at Narwhal is we do help you build more productive applications. And we do have these extensions along with the Angular CLI, helps you to build more manageable data management with RxJS stores and upgrade your applications and all that great stuff. And you can read Justin's documentation at narwhal.io/nx about that. And if you like to follow along, and I have lots of resources for you in my slides, you can find them on bit.ly WebVR AR. And I have an AR demo on GitHub here for you, but I will tweet my application that we are going to see today. So just want to tell you where we are, like why it's a very good time right now to start learning about WebVR and start introducing it to your, at least product managers, you know, not to your applications, but at least go back to your teams and just talk about it a little bit. And where we are in WebVR API and what's going on in there. And some of the tools for AR and VR that's available right now for us and very easy to use. And finally, I will show you some code and talk to you about like why it's a very good idea to use it with Angular. So a little bit of terminology. Reality is where we are right now. And virtual reality is the total edge, the other end of the spectrum. So when we create our own realities and everything is virtual, we are totally immersed in an environment and not just like this, you know, meeting that you're very bored, you can just run away and create your own reality and live in that. Of course, there are better uses for it, and you can actually, there are so many medical uses right now. Researchers are using VR to deal with pain, and it's a great educational tool and not just for running away from your reality while you're in a very boring meeting. So previously I worked at Autodesk. We were creating this VR authoring tool, and our main purpose was to enable Smithsonian Museum, it's a natural history museum in Washington, D.C., to allow to create these great experiences. And they could have created just 3D experiences. They were able to just scan everything that they have. They're creating this amazing archive of every artifact that they have. But it's kind of not enough. So it's a really different experience to just see and turn things around, but just to also be able to walk around this mammoth and you know, make yourself small or big and interact with it and just be the animal that's actually going to be eaten by this animal is a very interesting experience. The other thing we were able to create for them is not just to see what was being discovered, but where it was discovered. All these artifacts that came out, so like what did the cave look like? How did these people dig these things out? So it's a very interesting experience. And you have all these virtual tours and all these scans available for you on 3dsi.edu. You can hold the Lincoln's deathbed mask in your hand and look at all these interesting stuff, so it's really cool. So you might say these are all very like edge case things, but if you have any kind of data that you're displaying and it is related to the real world, WebVR is also a great tool. So this is a great article that I recently found by Vladimir. And he talks about creating great experiences. So our brains evolved to work around in a 3D environment and in a spatial thinking, way of thinking. So if you see a 2D graph of how much people make on, even if it's in a VR environment, that's not very meaningful if it's an abstract 2D image. But if you have real size people around you that you're surrounded with, and you can actually see the differences between them, that's a totally different feeling. And you're creating an experience, and you're creating a feeling. And that's true for most of the products that are used in any kind of 3D environment. So, and he has a very interesting article if you'd like to check it out. And in between virtual reality and our own reality, there's augmented reality, which is a way of extending our reality with some 3D or any kind of information. So I'm mentioning this because they're all together called mixed reality, and they're all using similar APIs. So AR is also using WebGL API, which is allowing us to create 3D on the browser, and also using some WebVR to allow the interactions then, so on. The additional thing AR is using is the media capture API, which has been around for a while now. So WebGL is pretty well supported. We've been playing 3D games on the browser for a long time, which is a really cool thing. WebVR is not as much, but it is available under a flag on Chrome if you can enable it by enabling the WebVR flag. And most of the browsers are on the same page about creating the same APIs available, making it available. And Firefox is leading the way. User media support has been around for a long time. We've been using it for like chat applications and any kind of video applications, but it's not working great with iPhone, unfortunately. And all these browsers are also helping us to create these experiences. They're making it very easy for us. They're creating these amazing component libraries. One of them is called A-Frame. If you are interested in the workshop today or tomorrow, the WebVR workshop, I think you can get to know A-Frame a little bit. It's very much like Angular components, HTML-based, very declarative way of creating 3D experiences. But you still have to get yourself a little bit familiarized with the idea of creating a 3D world. Google has all these amazing 3D models. They made them available for you and allow the artists to upload these 3D models for you to be able to use at this poly website. And it's really nice because they're usually very low poly, and they're designed to be more performance. And the other place that you could find amazing artwork is Sketchfab. It's more game and artist oriented, so you have to be a little bit careful about choosing your models because higher polygon count will make it really hard for your application. So I really like the way A-Frame is making creating 3D experiences very easy, and it has a great documentation and everything, so very good user base. I really like it, but one thing that I think it's doing is it's a little bit confusing if you try to understand how it actually really works. It makes it really a bit hard to understand because to create a 3D world, you have to have the lightings and cameras and things like that, and they all live in a canvas. And with A-Frame, what you're doing is you're creating these HTML elements, and they look like an HTML element, regular HTML element, but they're not. So you're not able to interact with them as if you were interacting with any other HTML element. So I feel like it's making it a little bit confusing because Canvas is an XML, and it has its own way of acting, sizing and everything else. And I think these tools, these other tools, are making it a little bit more easier to transition from, having a very easy development environment to actually creating your own WebGL 3D environments. One of them is called Play Canvas, and the other one is Visor. So basically, they are kind of drag and drop, and then instead of creating HTML components, they allow you to change the settings on the canvas elements, which is, I think, really nice. And lastly, 3JS. That's my favorite. It's a library on top of WebGL, so it allows you to create 3D experiences very easily, basic with JavaScript objects. And it's been around for a long time now, and it has a great community. Started by this artist, Mr. Jube, because he wanted to create his 3D experiences, and there was nothing available out there. So he decided to learn coding, and then he did it himself. But now, most of the companies, Autodesk or Google included, they've been using their tools to create amazing experiences. Anyone used 3JS before? Nice. So what 3JS gets us is efficiency. It's very easy to learn. It's plain JavaScript objects, and it is really fast. It's optimized for us in many ways that we wouldn't be able to figure it out right away. And it allows you to write much shorter codes than writing the actual WebGL. And what Angular gives us, what I really like, is being able to put together the things that, package together the things that we want to package, and maybe give it to a designer or someone who doesn't have as much experience, and be able to just give some options and interact with the rest of our application. So what we will create is one component with some options and events handling. So as I mentioned, 3D lives in the canvas, and we create a canvas element as the element of our component, and we can define some events here. So we are display pointer restricted and not restricted. These are events that are defined for us. That are enabled only when you are on the VR experience, actual VR experience, when you put it into a device, or when you click on a button to enable the VR. So we don't have to worry about that. It's defined for us. But we have to handle what we wanted to do afterwards. So the other things that we do is get some inputs. So this is how we work with the options. We can define the models that we want in our experience here, or like the lighting or anything interesting. And with the view child's decorator, we have access to the canvas. So we can work directly with the canvas and not touch the DOM elements directly using the native methods. And we have the host listeners and the lifecycle hooks that we can take advantage of, like the ng-init. So inside our ng-init, we are going to create our 3D scene with 3JS, and we are going to create a camera, and we are going to create our renderer to get things started. First thing we do is initiate a 3D scene, and then create a camera object. It's very easy, and it takes 4 different arguments. First of them is focal, field of view. Okay, good, I remember. And the aspect ratio, near clipping, and the far clipping. And near clipping is what you don't see closer to the camera, and far clipping is what you don't see after that certain point in the camera. So you don't want to constantly be rendering everything inside your camera's view, so you wanted to limit it for efficiency and sometimes to hide things too. And one thing to remember is to give the width and height as the aspect, to calculate the aspect ratio. Otherwise, your images will be distorted. But you can, for performance reason, you can divide this into two, or like, you can make it smaller, but the aspect ratio has to be the same ratio with the canvas width and height. And normally, outside of Angular, what we do is just append the element directly to the DOM, create a renderer, and then append it to the DOM element. But instead, there's an option to give to renderer. You can give options to the renderer, and one of these has to be your component's element. So instead of directly appending anything to the DOM element, just remember to use your component's DOM element. So finally, you have to enable renderer's VR setting to be true. So what renderer does is, I think I haven't explained. So you have a camera. Anyone used a film camera before? Anyone that old? Okay, well, maybe, I don't know, it's a retro thing to do now. So basically, what renderer does is takes the information, your viewpoint from your camera, and then translates it into a 2D environment, which is your canvas. So it is doing the same thing as taking a picture and then printing it on a paper or something like that. I haven't shown you what we are looking at, so it went crazy. So we have a bunch of elements, and if you can see, in the middle, there's this thing that I can try to show you, like how it's looking at things. So if I enter a VR environment, and if I try to rotate my point of view, I'm not able to hit any objects. So there's this circle right in the middle, if you could see. So that is and when it hits an object, it's very hard to do it here. It is changing the color of the object. It's just telling us, like, we have selected that. So what we are trying to do here is to, instead of using a gamepad API or any tools, we are trying to create this experience of looking at an object and being able to select it or hover over it. So to do that, we use this thing called ray casting. So basically, it's kind of like putting a laser on your camera, and whatever is intersecting with that light is going to be selected. This is kind of like a cheating way of using interaction, but it's being used very widely because it allows you not to have any kind of hand tools and be able to create these experiences for cardboard, for example. And it's really nice. But in the future, in the very near future, with the WebVR 2.0, it will be integrated directly to the WebVR API, so we wouldn't have to use any kind of ray casting. So what I'm doing with the crosshair thing here is create that little donut, which is attached to my camera, and it's showing me where I'm looking at and where I'm aiming at. And it's basically a mesh, which is the term that we use to create the objects and define an object and put every definition that we need in it. And two definitions that we need, what the object will look like, which is the geometry. And in this case, it's the ring geometry, which makes it like the donut thing. And the other thing is the material, how the light is reflecting off of these objects. So we can actually see it. So we put these two things into this grouping thing, which is the mesh, and that's how we define any object. And on top of it, we can give many other options. Like in this case, I'm defining the basic material and then giving some color and opacity. Once we create a mesh, any kind of object, they are created in the 0, 0 coordinates of our scene, including our camera. So that makes it impossible for us to see anything because everything is on top of each other. So I'm moving my crosshair a little bit further so it will be in front of my camera. And by adding it to the camera, what I'm doing is to attaching it together. So it will be always moving wherever I'm looking through the camera. So once I have that, I'm adding this room thing, which is just a box that I'm in, and the camera, and some lighting so I can actually see anything in my scene. So far, we have the camera, and we have the renderer defined, and we have to add some objects in it, or particles, or wherever you like, and finally animate them, render them. So 3D objects is mentioned before. It needs three things: a mesh to hold things together, and the material and the geometry. And normally what we do is just initialize a 3D material from 3JS, and then add the material to it. And then once we have the mesh, the whole object defined as the cube, we have to add that into our scene. Remember, I mentioned everything is an object in 3JS. So everything is inside a scene object. So everything has to be added to the scene object for us to be able to see. And then we can define some animations on our objects, which is very much like the CSS transitions. So you can add to the rotation of X and Y. So in my particular case, this is a little bit looking, more complicated, but it's not. What we have is we have just randomized positioning, and we have some randomized scale to be able to create like 200 objects at the same time at once. And one thing that that might get scary for some people is the vector thing. What vector is defining is basically defining a 3-point location. But it sounds like a lot of math, but it's actually defined for us, unless you're trying to do something very specific. If you're doing something random, it's very, very easy to use. And finally, we add everything, all of our objects, to our room object. The other thing that you can do is get those amazing models that I told you about from the Poly website or anywhere else. And to be able to do that, you need to have a loader and specific to the extension of your model. And in this case, we have an OBJ, and then we have a material that's defined with MTL extension. And we are loading them together and attaching the material to the object. And finally, we have to render everything over and over. And that's why we need to use the request animation frame, because not to make our users very dizzy, we have to render everything in 60 frames per second. And we talked about animate. And one very useful tool is to have also groups. In our case, our room was kind of acting as a group, but it's very easy to group things together and then animate them all together and add them together. And Raycaster is a library that is defined for you, so it's very easy to initialize. And then once we have it, we have to attach it to our camera and then set it from the camera and then calculate the intersections. When it's intersecting, we have to do the selection or any kind of interaction that we need. Okay, yeah, I was worried that I was running out of time, but I'm doing great. So this is the end of it, and I can show you the code briefly. So there are some more implementation detail, but it's pretty much it. So we've learned what we need to use to create our WebVR experiences. We need to create a 3D world with a camera, lighting, and we have interactions with raycasting, and we have these options to load any kind of object and interact with them through the raycasting. And you can find some of the other details on my code, which I will tweet later on. And if you are curious about the AR, I have this AR demo and that you can take a look at. And you have to have this image. You can just show it through your phone, which is called the hero image, to be able to see anything on it. And it doesn't work on iPhone, as mentioned. Well, thank you for your attention. Please follow me at iSomething on Twitter. I will tweet the demo and the slides later on, and check out the rest of the code examples there. Thank you. Awesome.